Hi, I'm Ann Moran, and I would like to welcome you to our live webinar series. Today's educational topic is on HVAC energy conservation strategies, but we also have some guest speakers, so we'll be bringing to light some additional lighting energy saving strategies as well. So without further ado, I'd like to cover a few basic just ground rules and then make introductions, go over our agenda, and we'll go ahead and get started and complete it within an hour. So this is action-packed. We actually have 4 guest speakers in addition to myself today. So again, welcome. We are just pumped and excited that you're all here today to hopefully pick up some additional strategies on how to incorporate energy-saving strategies for your facilities and buildings. Again, our webinar lasts an hour, so it will be action-packed. If you have questions, we ask that you save them to the end, and then you can email any questions in, and you can address them to all attendees or just to me, and then we will address those questions in the end. We do record this series live, so if you would like to listen to this again, you can. We'll make a YouTube link to be able to link and listen in. And if you'd like a certificate of completion, we will mail that at the end with a survey that we will send out to everyone, as well as a PDF copy of today's session. So without further ado, I'm going to go ahead and make introductions, turn off the webcam, and thank you again for joining us here today. So just hold on here shortly. So with me here today, I am proud and honored to introduce our guest panelist. Mark Brucker is Managing Partner with Burton Energy Group, Manny McDonald, National Accounts Executive with Phoenix Energy Technologies, Andy Miller, Vice President of Sales with FSD Lighting, and Danny Miller, President of Transformative Wave. And I'd like to add, this is a very talented, sophisticated, educated group. I've gotten to know all of these folks very well through the Edison Energy Institute, and all of them are experts in their industry and are excited to be here today to again, share some knowledge and hopefully give you 1 or 2 advanced tips for how to bring energy conservation initiatives to your facilities. What we'll be covering from start to finish is we'll talk about what are investment drivers. How can we incorporate capital or even expense-related strategies, and what are the investment drivers to make that happen? We'll talk about, at least from my perspective, how do we identify HVAC energy saving strategies? And I'll talk about 3 specific areas: audits, expense, and by analyzing our assets. We'll talk about why benchmarking, looking at that gap analysis, where we are, where we want to go, and then incorporating best-in-class HVAC energy reduction strategies. From there, I will turn it over to Mark Brucker. He will do an in-depth dive on demand control ventilation and talk about some specific utility-related energy-saving strategies. And then we'll turn it over to Phoenix, Mandy, to talk about monitoring and technology strategies. And then Andy Miller will talk about LED lighting retrofits for warehouse applications and cost-effective strategies for powering parking guidance systems, as well as a few other tips. And complete with Danny Miller, he will talk about VFDs, DCBs, and economizers, and getting the most out of your HVAC systems. So in order to keep this live and interactive, we are going to launch a poll. And if you could just take a moment here and vote on your screen. If you are listening but not live, that's okay. We'll close down this poll right after we get to about 80% complete. So what are your top 3 facility investment drivers? Is it corporate sustainability goals, policy drivers, reducing energy and operational expenses, community leadership, business need, customer expectations? So take a moment to vote. This is good. We've got an interactive audience. We're at 43% voted. You're very quick, 50. And as I mentioned, I'll close it down at 80 and then share those results. So we are at 80%. I'm going to go ahead and close and share. And our audience here today, the majority of you all are tied around corporate sustainability goals, reducing energy and operational expenses, and business need or customer expectations. So that is really what is driving today's audience. I'm going to go ahead and hide that and then jump right in. So when I look at facility investment drivers, really from an HVAC standpoint, what I see are people want to reduce energy consumption. So there are 4 costs associated with managing HVAC equipment. You have your maintenance, your energy, your repair expense, and the capital. And by doing, a lot of different initiatives, we can really drive down that energy consumption associated with the HVAC equipment. With a lot of our larger clients, I see really corporate goals that are driving the investment that facilities are making, really starting with energy, environmental, and sustainability. I have one of our customers that their goal is to drive large-scale initiatives and positively impact the environment. And HVAC efficiency programs represent 25% of their savings. Again, 25% of their total overall savings. And when we talk about total kilowatt hour savings, reduction in kilowatt hours, this is where HVAC and lighting are great forces to help with that overall strategy. So not only are we seeing energy, environmental, and sustainability, but going beyond ourselves, beyond our companies, and saying, how can we leave this earth better than we left it before, in our community, in our marketplace, and in our workplace? So the goals now are getting bigger than just individual savings, but how can we really leave this place better than how we came in? So stewardship for the environment. A lot of folks are seeing that from an HVAC standpoint, they've got equipment that is now older. They might have deferred some maintenance or expense-related items because, again, they're just trying to control their budgets. And because of that, they have aging assets that are R22 units. R22 is going to be phased out. So it makes sense to proactively take a look at investing in new capital that's more energy efficient. So we'll talk about that. Comfort, obviously, is something that can take place where, again, that the units are finely tuned, and again, we might have newer equipment in place. Policy drivers, as the audience voted today, is there. It's important, but it's not the primary investment driver. So how do we identify HVAC energy savings? Well, I love this picture because this shows units that are not operating efficiently from an HVAC standpoint. So again, the purpose of an HVAC unit is both to provide cooling and to remove humidity. And guess what it can't do if that unit is dirty? Guess what it can't do if the unit is not charged correctly? Guess what it can't do if coils are matted? It cannot reject that heat. It cannot operate at peak operating efficiency. So we'll talk about 3 different ways that engineering excellence takes a look at identifying HVAC energy savings. But I'd like to point out first, really, what are we talking about reducing? We're talking about how to, take advantage of free cooling or take advantage of not running that compressor. So this study was done by Ramin from Southern California Edison Technology Labs, and he actually spoke at a Professional Retail Store Maintenance Association conference, a PRISM conference, and really talked about how you can reduce energy consumption. And what he said was the compressor is responsible for 83% of the power draw. Evaporator fans 11.5 and condenser fans 4.4, miscellaneous a little bit less than 1. But what happens when you have multiple faults that are occurring at the same time with an HVAC unit? In this situation, you see 2 faults. A unit is undercharged, and a fancy word for condenser airflow reduction, the outside coil is dirty. So in those situations, what we see is total power consumption increases. We have a gross cooling capacity situation where that is reduced significantly to 68%. So the capacity of that unit is reduced. And on top of that, the efficiency is reduced. So the EER, or the energy efficiency ratio, or how many BTUs you get per watt of electricity is consumed. So again, what we're looking at is how can we reduce those kilowatt hours? How can we reduce demand? Well, we're going to take a look here today on different ways that we can maximize the efficiency of these units. So we can identify HVAC energy savings by auditing sites. This chart right here just shows a sample where a client asked us to audit 30 sites and say, where are there opportunities for improvement? And bottom line, they already had an EMS system in place. So it was not with set points and schedules, but it was really identifying units that should be replaced that were older and inefficient, looking at demand control, ventilation, and then conditions of the equipment. Again, we talked about heat rejection, coil conditions, economizers, general repairs, dirt, again, filter conditions that are going to lead to evaporator coil dirty conditions, belt and pulley refrigerant charge. So one of the first methods is actually auditing sites. Second, I like to look at repair trends. So for a lot of customers, we just look at which HVAC repairs are happening most frequently, and more importantly, why. So for this particular client, they don't include coil cleaning in their maintenance. And this showed up as their #1 repair trend that happened most frequently, followed by thermostat-related issues, belts, clogged drains. So when I look at energy efficiency strategies, I'm going to look at, again, maximizing heat transfer, making sure coils are clean, looking at low refrigerant, leak check and repair, again, making sure those units are charged properly, looking at belts and how those units are set up. So this is where, for this particular client, we actually incorporated a strategy to make sure that we were cleaning those coils, make sure that, we were checking superheat subcooling pressures and temperatures to make sure that those units are charged properly. So again, we can look at repair trends. The last way from an HVAC standpoint is really by analyzing those assets. So here I've got a particular client, and that's what we've done. We've looked at the equipment, the oldest units to the newest units. And this is where we can go further to say, well, what's the EER of this unit? What is the projected savings and the energy cost with an old unit versus a new unit? And then how can I build an ROI or payback by not only looking at the improved energy efficiency savings, but looking at deferred maintenance, looking at repair cost avoidance. So what we really want to do is a gap analysis. We want to say, where are we now? Where do we want to go? What is our clear focus on where we're going? And where are the biggest savings opportunities? So I'm not going to get into the detail of this, but what's important to know is, hey, what's your Energy Star rating? What is your energy cost per square foot? Where can we maximize savings and where's the lowest hanging fruit? And benchmarking or doing this gap analysis really starts by saying, what can we do that are behavioral issues, no cost, low cost? What are PM or expense initiatives? And then what are the capital initiatives that we can invest in to provide these additional savings? So it all starts by looking at the utility bills, looking at where we are and where we want to go. And I'm going to go ahead and launch our second poll right now. And that poll is, do you benchmark your facilities? Yes or no? Do you benchmark your facilities? And again, when I'm talking about benchmarking, I'm talking about any type of a gap analysis. I'm looking at cost per square foot, energy cost per square foot, Energy Star ratings. So we've got 73% voted. You guys are getting even faster. I'm going to go ahead and close this, share the results. Turns out 55% are doing some type of a gap analysis, 45% are not. That's good. Because it's important to understand your buildings. Again, the majority of this is focused on HVAC, but with Andy here today and Mandy, we'll be focusing on really total buildings. What can we do to impact energy consumption? And Andy will be focusing on some lighting-related energy saving strategies. So wherever we are, we want to understand the building, benchmark, look at the key indicators for you, and then look at some of those areas that can really impact energy consumption, such as the HVAC and lighting, and then set goals for where you want to go, and then obviously implement these programs. So we're going to analyze, we're going to reduce costs, look at where we can do that, and then really generate what these savings might be, and then demonstrate it through test pilots, and then go ahead and implement that across the board where it makes sense. I love to take a look at even just general HVAC related maintenance savings. So again, I talked about earlier low cost, no cost, things like condensing unit coil cleaning. Something as simply as adding a condensing unit coil cleaning to your maintenance, which is roughly about $100 if you've already got a technician on site, can produce savings, a payback really of less than 0.33 years, a payback a month of really 4 months, and an ROI of 302%. So things like making sure you've got good heat transfer, making sure the economizer is fine-tuned, looking at making sure that unit is charged properly, or the thermostat is properly calibrated, are maintenance or recommissioning items that are important to strategize as a part of your maintenance. And I like to look at something as simple as a 10-ton unit, the kilowatt consumption when that unit is clean versus dirty, and then the energy savings. Again, and then just the reliability of the components by making sure that they're not overheating. And then even just something as simple as a refrigerant charge analysis. And again, these are just manual little operations. Everything right now, when we talk about Mandy and Danny and Mark, they will automate it, but it's neat to kind of take a look at, if I've got just a simple 10-ton unit and it's not operating efficiently, it's operating, in this case, I've got a seasonal energy efficiency ratio, which is talking about really data across the country in different temperature zones as opposed to laboratory conditions with an EER. But if I've got a unit that is undercharged, it's not operating efficiently, let's say it's operating at a 7 SEER, it on average might be costing you $2,777 to operate that, versus if you've got higher efficiency units, you can see how this energy consumption is decreasing. And again, we've got sophisticated calculators, but I love to just take a look at basic bottom line savings. So we'll talk about all of that today, as well as how do you prioritize, what's critical. And we talked about the facility investment drivers. It's important to know how can you impact your customer experience, how can you impact the environment, and what are the preferred drivers to get some of these projects launched. I know it's really important from our standpoint to help the CFOs, to help the C-suite build the case for planned unit replacements. So I have so many of our customers where over 30% of their units are over 10 years of age, and really even 15 to 20% of their units are past ASHRAE expected life. So I like to recommend to look at your assets and sort those equipment by age. So this particular chart right here represents one customer where you can see they've got a lot of units that are 27, 22, 21 years of age, and I have a lot of customers where it's even older than that. So what is the condition of that equipment? What have you been spending on those units? What is the efficiency of those units? And does it make sense to come up with a strategic equipment replacement plan to say, okay, if I've got 20% of my fleet that's beyond useful life and I've got 244 units, what would it look like if I start to budget and forecast? And this is where we'll put together 10-year forecasts. Not that you have to do that, but at least to start talking about how can I proactively put in a planned unit replacement program, and what would be the payback, the internal rate of return to justify putting in a program like that. And then again, minimize really expense as well as energy savings. So here's an example of where we'll put together an IRR, a payback, a return on investment, taking a look at replacing equipment, and the energy savings incorporated with that. We'll do cash flow analysis, as well as just looking at set points and schedules, and then mapping out what those energy savings would be. So that's just on a high level basis. I'm going to jump into another poll right now. And just ask a quick question if you're doing any kind of energy audits right now as it relates to looking at the energy savings that you could incorporate either through lighting, HVAC, etc. So are you doing any type of an energy audit right now? So we are at 56% voted. And I'm going to go ahead and close that, share the results. And it turns out 60% are doing some type of energy auditing. And I'm glad to hear that, because that's awesome, because that's the roadmap for understanding that gap analysis and where you want to go. And here's another perfect example as to why. So there are significant energy savings by replacing those old inefficient units, anywhere between $1,200 to $2,000 for a typical 10-ton unit. But we'll let some of our other speakers here talk a little bit more about energy savings and how you find that. Bottom line, it's a good investment to look at energy efficiency strategies. And with that, to stay on time, I'm going to go ahead and flip the keyboard here and change presenter to Mark Brucker. Mark?
Thanks, Ann. Can you hear me okay? Oh, are you making me the presenter? Okay, hold on, sorry. Two seconds. Can you see my screen yet, Ann?
Mark, I don't know if you're hearing anybody else, but I'm hearing you.
You are, okay. Can you see my screen, Danny?
No, I can't. It looks like we lost the
Interesting.
the screen there. Andy, are you still there?
I'm still here.
Are you not seeing the webinar either?
I see.
Mark,
I see it.
Here, I think I know how to do this. Hold on. Okay, hopefully you guys are seeing it now. I'm going to just get started. Is that good?
that's good.
All right, we're moving. Sorry for that. I'll make up time. Thank you for allowing me to join, Ann. I appreciate it. And I'm going to cover just a few things on optimizing your ventilation. Since we're talking HVAC, this is a great something to contribute to. It's a way you can drive lower energy usage, either at the time of replacement, which Ann talked a lot about, or through a retrofit situation, which Danny will talk about with the transformative wave solution. So I'm going to talk a little bit about ventilation, how it impacts your facilities, how it's measured, how you can drive energy savings, and then a couple of interesting incentive programs that can help you try this out at a very low cost. So with that, I'll move forward. So first of all, why is ventilation important? So one, it got at least its own letter. It's the V of HVAC, and logically, you know, our air conditioning units, they cool or heat air, and in order for that to then make a difference on the space, we've got to move that air around, and that's the ventilation side of this. So we're removing heat, we're adding heat, we're moving air to help you all feel comfortable. Not just temperature, but of course, we're also removing things. We're moving moisture in some cases. We're removing things like CO2 that build up from people. If it's a restaurant, you're removing smoke and other fumes from the cooking area, or in certain types of equipment, maybe putting off gases, battery plants, for example, in distribution centers. So it's important to keep buildings healthy, and also is very important for maintaining balance. If you look at ventilation, it's really a system. So any place you've got exhaust fans that might be pulling out unwanted fumes or air or CO2 or anything, you got to make sure that's coming back in equal volume so you don't end up with negative pressure in your building. So those are a few areas of why ventilation is so important. It's also very important from a code standpoint. ASHRAE 62.1 legislates or makes strong recommendations on what we should be doing for indoor air quality. Indoor air quality itself obviously has been an issue for a long time, but it really became to a front in the 1970s when, in an effort to significantly reduce the energy use in buildings, we tightened them up. Had a lot of leaks in buildings, I think before that time. Buildings started to get a lot tighter. They cut off outdoor airflow. They sealed all the windows, and we started to get more energy efficient buildings, but started to see things like sick building syndrome, where you had too much buildup of CO2. You had other things that were building up in buildings. And so around that time, ASHRAE came out with this standard, very first published in 1973, to provide engineering guidelines on how to make sure that you're getting the proper amount of air in the buildings where we've got people occupying them. Minimum ventilation standards, it became a regulatory requirement, part of building codes in many areas, which as a building owner or operator creates liability. So you as the owner or the operator of a space, have a liability because 62.1 exists to make sure that your buildings are meeting that requirement. And then if you're doing Energy Star, Ann mentioned benchmarking. If you're going to try to get an Energy Star award, it's one of the things that a PE has to sign off on, that you're actually meeting proper indoor air quality standards. So how is ventilation delivered? One, it's delivered through your packaged rooftop units, probably bringing in air that way, or maybe through separate air handling systems, usually on the roof. You're kind of looking at a space. If you've got a VAV system, for example, you might be seeing the air come into a specific office or a conference room, and that air ultimately has to come from the outdoors through some kind of fresh air supply. We've all probably had the experience of cramming too many people into a conference room, and at that point in time, after half an hour, you're thinking, boy, I wish these guys had paid more attention to ventilation and indoor air quality. So it's a real-time example we've probably all faced at one point or another. So how do we ensure that we've got adequate ventilation? One, as we said before, the minimum damper position. If you've got rooftop units, they've got an outdoor air damper, it's not supposed to be completely closed unless you've got controls in place that let you know how much air, how much CO2 buildup you have, and to be sure, this only works if you could keep your supply fan running in some way. So this minimum damper position is important. If you do that, you can also measure, and CO2 is a pretty good indicator of the proper amount of ventilation in any space that has people in it, trying to keep that CO2 measurement below 1,000 parts per million. Starts to get close to 1,000 parts per million, you open the outside air damper further, and that brings it back down. And that's really what creates this whole concept of demand control ventilation for spaces where people are creating the unwanted gases. And so trying to keep that measurement below 1,000 parts per million is the requirement. And then lastly, I would say, how do we measure it? In a space that has a lot of exhaust fans, restaurants, for example, differential pressure is a way that you might measure if you're getting the proper amount of ventilation. CO2 would almost never build up high enough, but if you're not getting enough ventilation in, then you're going to lose, start getting it in through somewhere, drive through windows with the bugs and pulling your doors open. So that's one way to measure it. So ventilation wastes energy, and this is something, if you've analyzed, rooftop units that are in a typical store, especially 24 hours, and look at the energy use, you think it's the compressor. Everyone thinks that's the biggest area. I found ventilation can be 50% or more of the annual energy usage of a rooftop unit. So this is something you really want to target. Fan energy, if it's running at full speed, you really only need that for the worst conditions, when you're in stage 2 cooling, when you need the maximum amount of makeup air. And if you can slow it down through the fan curves, you can save a lot of energy by doing that in the right way. Heating and cooling energy, this is where demand control ventilation comes in. You think, obviously, if you're bringing in too much outside air, your CO2 level is well below 1,000, and you design for the worst condition, then you're bringing in more air than you need. You're having to heat that air. You're having to cool that air. It is causing you to use more energy than you need in that situation. So before we get this concept of demand control ventilation, only bringing in the right amount of air to cover either what's being pulled out in a kitchen environment or enough to give you the fresh air you need for the people in the room. So strategy, this is something that comes from DOE's Advanced Rooftop Campaign, and you'll notice that for new HVAC units, they recommend having demand control ventilation purchased on the new unit, having CO2 sensors in place and the proper programming, zone level EMS options to cover it. For existing HVAC units, there's the advanced RTU retrofit. Catalyst is a great example of that, award-winning, the ability to help you deliver that kind of level of demand control ventilation strategies without having to replace with a new unit. So these are the cool things that you want to do. To keep moving forward, because we got some great speakers, a couple of great incentive programs to think about if you want to maybe take maximum advantage of these strategies. The ComEd Small Business Energy Savings Program, specifically for sites that are less than 100 kW. That would be a retailer probably in the 25,000 square foot or less. Quick serve restaurants, most of them are eligible for this. The combination of incentives in ComEd can almost fully fund some of the upgrades to the DCV VFD strategies. They also have a great rooftop unit replacement program. We've worked with some large national accounts to leverage for replacing your HVAC units. ComEd New York has just come out with a new program. They've doubled essentially their custom incentive. And if you go through different models of your HVAC usage, this is pushing it up in some cases above the incentives we've seen in ComEd. So keep your eye on that if you're looking to test this out. ComEd, ConEd, and then SoCal have been great places to really consider leveraging as part of these incentive programs. So that's I think all I had for my slides. I think am I turning it over, Ann, to the next presenter, or are you taking it back?
I will try to take it back if I could. Let me try that now. Okay, good. And then I'm going to turn this over to Mandy here in just a second, hopefully. So can you try to turn the screen back to me, Mark?
I can. Let me hold on a second.
That'd be great.
Let's see it. Did I pick the right engineering excellence?
You sure did. Thank you. And
right.
I would like to just here officially thank you. I thought your topic was awesome. And I just want to ask one question before we move on to the next speaker. You talked about a lot of great things. Ventilation, demand control ventilation, the Department of Energy Advanced Rooftop Campaign, incentive program. A company wanted to double their savings, double their energy savings. What would be something that you would recommend as a top strategy?
Well, I think the biggest area of savings we've often seen is that the balancing of the ventilation speed. If you've already done lighting and you really want to tackle energy savings, we find that the VFD strategy, usually deployed in concert with demand control ventilation, is a great one. So depending on your environment, DCV itself may save you a ton, may not, depends, but there's usually great incentives for it. And, you know, it's, but that variable speed ventilation is really where I think you want to take advantage of.
Words of wisdom from Mark. Thank you so much. I'm going to go ahead and turn everything over to Mandy McDonald now. So I'm going to turn off my screen and then advance the slides. And Mandy, I'm going to try to turn over the keyboard and mouse to you this time successfully. Hold on.
Okay, great. Thanks.
So I'm just advancing these slides and then we'll turn over to you.
Let's go back one more slide.
You got it. You're up, Mandy.
Great. Thank you, Anne. Well, today I will be taking just a few minutes to walk you through what I think is a simple yet very impactful customer scenario that really demonstrates how you can use IoT, the buzzword, or the Internet of Things to drive HVAC and lighting efficiencies out of your existing systems and energy savings, drive energy saving strategies. Now, with this particular customer, this scenario, it started with a request from a theater customer that I'm sure many of you will be able to relate to it. They had a very specific need. They wanted to be able to automate their schedules in real time using their existing systems without having to invest any capital to do it. Very challenging. But most importantly, they wanted to be able to measure and verify the dollars they were saving on this project in order to validate the strategy using their HVAC runtime. Let's see if I can get it to move in. There we go.
Thank you.
But what they really wanted was more control out of their systems. So let's start with what they were doing in their previous environment, like in this first scenario. You can see that the units were running in all 5 auditoriums based on their operating hours at 100% utilization, wasting hours of runtime and yielding absolutely no energy savings. But if you look at this second scenario, this is what they're doing in their current environment. And that is adjusting their schedules to coincide with movie times instead of operating hours. They're now able to achieve dynamic schedule management, which is reducing their run times and yielding significant energy savings per month. Now let's go back to that first scenario again and take a look at the way the system is set up. When you go into the system, you can see that you're going to want to change the start and stop times based on operating hours and the zone and supply temperature. However, these are static points. Once you commission it, the building is going to operate the way it was set up. The only way to change it is to manually adjust the temperature either up or down. Very similar to the AC in your vehicle. In order to adjust the temperature, the vehicle must be turned on and will operate at the temperature that you set. So what am I getting at? What does all this mean? The bottom line is that there's money being left on the table. In order to reverse that, you want to take control and reduce the amount of hours that the units are running, period. It's really that simple. What you really want is that 22 hours of reduced runtime per day and 4,000 energy savings per month. So how? How do you gain control and achieve energy savings? The simple answer is by adding IoT points such as occupancy, feeds, and point of sale data through a software application. And the reason you want a software application is that you have to be able to command and automate in order to create a proactive versus a reactive environment. You want machine-to-machine automation with little to no human intervention. So let me give you the keys to automation. If you are managing to 2,000 schedules every morning, you can't do that with just people. You must do it with machines. Then once it's deployed, you will have an automated energy reducing strategy, the tools you need to measure and verify that strategy, And now you can validate it through the HVAC runtime. That's all I have for today, Anne. I don't know if you want to pass it on to the next person or any questions. I can't hear you, sorry.
And I think you're on mute.
So is that better? Can you hear me now?
Yes.
Yes.
So Mandy, what I was saying was I was on pins and needles, and I loved how you had the clear focus with 22 hours of reduction and then the how. So what is the biggest struggle that people run into as they're setting up the how, the occupancy, the weather, the command and automate? What would you say is the biggest challenge, and how do you help people do that?
Sure. I'm sure many people know that it can be quite challenging to pull information sources from, different data points. So a lot of times IT has to be involved. That is probably one of the most challenging areas, but it's not impossible. We're doing it every single day with many different types of customers. And I think the main point is that they need a IP address and need to be connected to, the system. So I think that's probably the biggest challenge there. Does that answer your question?
It sure does. I really appreciate the insight. And with that, I'm going to go ahead and turn it over to Andy Miller. We have 2 more guest speakers, so everybody stay with us. And Andy and Danny, I'm going to try to challenge you to stay between 10 to 15 minutes. And all those folks that are in our audience today, if you can stay a little bit over in an hour, I promise they'll be very exciting. So Andy, I've just given the keyboard and mouse to you. Can you operate, or would you like me to push through?
Why don't you push through, Anne? It wasn't working before.
Go ahead, I've got it.
Okay. Well, thank you, Anne, and everybody on the call. I appreciate it. My name is Andy Miller with FSC Lighting, and we're just a little bit about our organization. We're out in Southern California as a manufacturer. We go nationwide. I've known Anne for quite some time. Next slide, please. So as you can imagine, our organization gets into a lot of different applications that are applicable to the attendees here on the call. We're going to focus a little bit on warehouse, distribution, fulfillment center applications, and some retail applications today. Next slide. One thing that in working in this industry for over 17 years now, one of the things that I find interesting with organization manufacturers is a lot of folks have a lot of manufacturers have their own style of lighting controls. What we've taken a different approach here at FSC, and we're able to integrate, ask questions to the customers, to our client base, and find out what the customers want to achieve, and then integrate a lighting control strategy based upon those wants and needs. With being that we're in California, we have to comply with projects here in California that comply with Title 24 and Title 20, and those Title 20 and Title 24 are being pushed out across the country. As of today, the Northwest, the Northeast has seen a lot of what has been gone on in California. It's been pushed off across the U.S. These control strategies since we don't make a lighting control system, this allows us to integrate a lighting control strategy for the different applications. Next slide. So what our company looked at holistically for warehouse and distribution center applications is customers in the Internet of Things, IoT world. Customers are looking to make their buildings smarter, so put more data into the building. And how do you get there? So what we've done is we've actually filed and we're granted a patent. We're calling this Power Plus, but this allows the luminaire to power up different different items, different devices within a building, like a security camera, RFID readers, Wi-Fi, asset tracking, data, things that you're going to need into a building and utilize in a warehouse, distribution, fulfillment center application by putting basically an outlet on the luminaire, your light fixture, and powering up a secondary device. This will eliminate your installation costs for these other devices, because we're not doing home runs any longer. So this is something very new that we've thought long and hard about, but we just released we're granted this patent. So this is something that we're bringing to market and going to be pushing out into the marketplace. Next slide. So fulfillment distribution centers, and including pick modules, are becoming huge in the online world. So you have these organizations out there that are online retailers that's all they do. Well, the bricks and mortar retailers are fast building out distribution pick modules in these spaces. You can save up to 70% of your energy versus your base a standard light fixture today with LED lights and lighting controls. Next slide. One of the things that we've looked at is, I or other manufacturers in the lighting world can come up with a light fixture, and we can save a bunch of energy on the lighting piece by turning it off. The second thing, though, is these high velocity fans. So this is a high velocity fan on the screen right now that draws anywhere from 300 to 500 system watts, half horsepower, 3/4 horsepower. And every 40 to 80 feet in these pick modules, these fans exist. Most of the time they have a pull chain, which means the worker pulls the chain when they want it on and they walk away. The fans never get turned off because you have that human element in the mix. What we've figured out how to do and to save energy over that 40-foot space or 80-foot space, we can save a bunch of energy on a retrofit, but you can save 3 to 4 times the energy by turning off the fans. And there's a way that we can turn off the fans from a lighting control strategy. We can turn it off based on occupancy. We can also take a look at that. Well, that makes sense from an occupancy standpoint, maybe during the summertime. But if it's the winter time in these warehouse fulfillment center applications, you may not need the fan on. But if you have someone, a worker hustling, running back and forth, and they get warm, they may want the fan on. So we have a manual override, and this is all based on temperature. So the fans would not turn on if it's a predetermined temperature. But there's a manual override, so you can turn on the fan. It is tied back to the occupancy. So once the space is vacated after 10 to 15 minutes, a predetermined amount of time, if you will, the fans will automatically shut off. So this is a great way to take a look at we're a lighting organization, but taking it one step further and looking around the space to find other ways that a client can save energy. Next slide. In a warehouse application, it's simple with high bay lighting is a no-brainer today. The luminaires that are in the marketplace are able to save 50+% energy versus the existing baseline, and then programmable sensors make it very, very simple to not only turn off your lights, but you can top when no one's in the space, but you can also top trim or shed some load on the top end when someone is in the space. So the human eye has a real difficult time understanding the difference between 100% of light output and 90% of light output. So what we've done is we'll integrate a light sensor, occupancy sensor, with dimming capabilities with a remote control sensor. So you have a remote control there in the screen there. You point that at your light fixture, at your sensor, and instead of running the fixture at 100%, you can dim it by 10 to 20% right off the bat and save an additional 20% off of that new baseline. We've taken it into the IoT strategy into the retail space. This is a discount retailer, Ocean State Job Lot, out of Rhode Island, and they've decided to retrofit their stores with new LED lighting. One of the things that they wanted to do is to combine the lighting and the HVAC via the cloud. So they want a cloud-based control strategy where they can dim their lights at any point in time from anywhere in the world. Secondly, they want to control their HVAC, change their set points at any particular given time based on their time of use or their stocking strategy. So what we were able to do is through a lighting controls device manufacturer and a software company is integrate those two. So now they not only can control their lights via the cloud, but they control their HVAC via the cloud, and they have power measurements. So we're able to now track and in real time knowing what each individual store is consuming at any point in time. Next slide. And here is a picture of the store, all new lighting for both back of house and their sales floor. And in this case, we are top trimming their lights. What this top trimming does for the store is it maintains their light levels throughout the life of the store. So they, as lumen depreciation does come in to play, they are able to ramp up their lights over a period of time, or over several years. Next slide. One of the things that some large manufacturers do not have the capability of, whereas a smaller guy like ourselves, is we can do prefabrication. So prefabrication means putting together a fixture so that an installer is able to put the fixture into the ceiling that much faster. So anything that we can take up off the contractor's plate and put it onto the manufacturer's plate is what we're trying to do. And then we also get into parking structures, which is another, that's the first and last place that a customer goes. And we have the ability to put together those applications as well. And with that, I'll turn it back over to Ann. And I think you're on mute again.
And the good thing is I put mute on all the time so you don't hear me when you're talking. But I would like to thank you. That was informative and action-packed. But here's my question to you. I just heard so many things, the Internet of Things. I heard about 6 modules, fan control. I heard 3 to 4 times the savings, 50% plus savings with high bay. If there was one thing that a retailer or customer could do when it comes to goal setting and what they want to achieve, out of all the things that you talked about, what's your favorite, or where's the biggest impact that's easy to do?
The biggest impact is to integrate a control strategy. You can upgrade your lighting all you want, but if you don't control it, it's not going to be nearly as much, and you're going to prolong the life of your lighting system by controlling it. Case in point, by top trimming, you're going to reduce the heat in a luminaire. That will prolong the life of the luminaire, the components inside that, plus it's a savings on the HVAC side.
I love that. Goes back to Duran's book of quality control. You cannot control what you do not measure and then come back full circle. So that was lovely. Everyone, if you can stay with me, we've got one great speaker left, Danny Miller, and I just love hearing everything he has to say. So I'm going to go ahead and turn off this and then advance the slides per your request, Danny, and get you started. Thanks again. Hold on.
Good. Thank you, Ann. Appreciate the invitation again.
Yes, it's my pleasure. I'm going to jump ahead. You mentioned jumping a few slides ahead. Is that correct?
Let's just go to slide 7, and a lot of this stuff's already been covered. There you go. That's great. So you can back up one slide there. Mark and Ann laid it out pretty well in terms of these various aspects of HVAC efficiency. The concept of optimizing what you have, these sort of 3 pillars of RT efficiency, assuming that you're not replacing the equipment, kind of the mission we have is to help people get more out of what they have. And there's clearly a place, and the utilities are seeing it. There's these great subsidies and incentives that are beginning to emerge. The R22 issue sort of helps to move these replacement programs forward, and the manufacturers make some great stuff. Our focus is what can we do with those units that are not going to be replaced anytime soon to elevate their level of efficiency and provide more accountability over those assets. And showed a lot of the images of what really happens up on a rooftop. And I know part of what Engineering Excellence does through their service and maintenance programs is really identify those operational issues, those repair and service related, maintenance related issues. And that's where it really starts is let's just make sure that these units are functioning the way the factory intended them to function. The charge is right, the coils are clean, belts are tightened, etc. And that's this optimized step. The second is this idea, what can we do now to upgrade the unit? And this is where RTU retrofit comes in. Some of the measures that Mark was referring to earlier. This allows us to take that unit and give it a better efficiency outcome than the best day it left the factory in, because we're fundamentally changing the way that rooftop package unit operates through these measures. And then, of course, and this is where Mandy and Phoenix comes in, and we do a lot of the same things in terms of perpetuating that outcome. RTUs are kind of the poster child for this law of thermodynamics, that things go from a state of order to a state of disorder. And it takes diligence or vigilance to be able to make sure that they stay operating properly. We've talked about the importance of economization, to use outside air for free cooling. If economizers are broken, then they can't provide that free cooling, and you're going to see more of that compressor energy usage that Ann's chart identified. So we always say it's what people don't know that's hurting them. And so putting users in touch with the real conditions, the reality of what's going on through fault detection, remote diagnostic tools, data analytics helps us really begin to then drive and have a long-lasting, sustainable outcome. I'm going to see if I can advance the slide here. There we go. So our area of specialty is about retrofitting the existing rooftop units. This is an example of what a basic RTU consists of. We won't spend time on that, but we will look at, I tried to advance, there we go. It's a little bit slow on my end. But Mark Brucker mentioned some of these strategies. At the heart of the RTU retrofit is making the fan variable speed, the ability to harvest the fan energy that comes from being able to make it more of a part load machine. It's essential that when you're slowing the fan down, though, that you don't just do it through a VFD. You need to make sure that in order to meet the ventilation requirements, that you are making a corresponding adjustment in the outside air damper position. And so you need an intelligent solution that can say, hey, as the fan speed changes, we now need to open the damper more, or we can afford to close it. So we're maintaining that same level of fresh air all the time. Integrated economization is where we no longer work off of just one data point as to whether outside air is basically our friend or not. Instead, what we're looking at is a differential. What's the return energy in the return air versus the energy in the air outside? And let's use the source with the least amount of energy. You can have a 70-degree day outside and have an 80-degree return air temperature, and you're still better off using the outside air. And that's what advanced digital economization does for us. And then, of course, demand control ventilation, where we can eliminate the overventilation that we often see when systems are just set up based upon the original mechanical design, which is minimum position for the worst or maximum occupancy we're going to find. And there is a lot of support. Somebody referenced earlier the Advanced Rooftop Campaign by the DOE. Originally, that was all about, whoops, we're running away here. Originally, that was all about replacement. And now what they've done is come out here a few years ago and said, hey, there's a place for retrofit. We really can accomplish a great deal by dialing these systems in. We've seen we've participated in multiple individual studies as well as a kind of a landmark study with the Pacific Northwest National Lab that has shown energy savings through RTU retrofit can approach or exceed even 50%, depending upon the climate and depending upon the as-found conditions. We basically promise about a 25 to 50% and are typically always able to deliver in that range. And Mark Brucker with Burton, they do a great job of monitoring what's going on out there in the area of the rebates. We do that. We work with them to try to make sure we stay on top of where these rebates for RTU retrofit are at. And these per ton prescriptive rebates as opposed to custom rebates makes it very easy for customers to access them. And this map just sort of illustrates this emergence of prescriptive rebates as utilities begin to really buy in around this idea that we can do better with what we have. And then there are these different advantages, even beyond these non-energy benefits that are associated with RTU retrofit. There is this ability to impact the maintenance cost. We're able through our technology to say when fan belts are slipping. We do have these demand response elements. We talk about efficiency, but load curtailment is another big frontier for us with HVAC because it's usually during the middle of the day or when it gets really hot that we're using the maximum amount of compressors, and the utilities are punishing you for using electricity during those periods. So the ability to be able to strategically manage the compressor operations through those time of use periods where rates are high or where demand charges are punitive is a whole other area. And that kind of goes into RTU coordination. How do you take multiple units and get them to work together rather than as just individual appliances responding to a singular data point, which would be the temperature in the space? There's also humidity control. LED lighting upgrades actually make your space, your stores, more humid. You've reduced the amount of sensible cooling that's available, and the units, if they aren't replaced or dialed in, they will short cycle. And in that short cycling, you don't get the 10 to 11 minutes that are required for a compressor to run, for moisture to collect on an evaporator coil and actually get out of the unit. Otherwise, the compressor will cycle off and that moisture just gets redistributed right back into the space again. So many retailers are fighting this phenomenon and don't necessarily always understand why it's happening. So this ability to see your assets, of course, is important through a building automation system, the fault detection, the remote troubleshooting capabilities. That takes data points, and this is part of what you get out of an RTU retrofit solution is enough sensors to be able to tell you more of what's going on. This thing just kind of runs away from me, and I apologize for the slides bouncing around, but I do want to highlight here lastly this economizer fault detection. One of the things that we've developed is this ability to provide the Title 24 compliant economizer faults and push them out in a visual way through analytics that are going on, looking at the different temperatures because of the sensors that we add through the Catalyst upgrade. And in this case, we're doing some math and we're able to determine that this economizer is healthy. But this next slide shows when it's not effective. We tell the damper to go to 100%, and what we end up with is only about 57% outside air. Or maybe we tell a damper to close, and we can still determine there's excessive leakage or return air that's bypassing. So I'm just still struggling there, but I will say that data, there's one slide I wanted to show, Ann, if you can help me find it. I'm going to try to go back to it. There we go. This data analytics. There's a lot going on now where people are kind of making a jump from their EMS up into big data for operational efficiencies. And we agree there's some there. We also think that there's these retrofit opportunities in between, but this is some Power BI, Microsoft Power BI technology that we've actually embedded into our EMS solution that enables you to track faults and lighting schedules that are being bypassed, all kinds of things. So this idea of the Internet of Connected Things and the databases that we can now accumulate, and then these great tools that we can overlay now to begin to help operators with limited resources, limited staff, really identify and pinpoint where their real issues are and prioritize where they put their limited resources or the service issues that need to be dealt with. So you've seen today, I think, through Ann and Mark and what Mandy does at Phoenix, and then Andy on the lighting side, there's a lot that can be done today to really improve the efficiency of facilities overall. So with that, I will close.
So Danny, you're not completely done yet. I've got a few questions for you. Two, to be specific. First of all, I want to compliment you. I love all your words: elevate, accountability, optimize, upgrade, control. I think those are all so important when incorporating a strategy. Here are my two questions for you. Let's just say that you've got a retailer out there and they've got whatever, 200 sites, 500 sites, maybe even just 50 sites. How do they know where to start? What would be what you consider the low-hanging fruit for which units do they retrofit? First question.
Yeah, sure. Units that are near end of life and you have a plan to replace those, say in the next 2 to 3 years, probably not where you want to make your investment. So we always counsel folks to find those units that are in that mid-range, and maybe we do see that even with new equipment, with the techniques that we apply, we can actually get about 30% more energy savings out of the VFD, even if the new units come with them. So, but generally, 3-year-old units out to maybe 12 to 15-year-old units tends to be the sweet spot. Bigger is always better. The larger units are going to produce the greatest savings benefit to you. And sales floor, of course, is where you tend to see that concentration of cooling capacity and fan energy, as opposed to the secondary units that might be serving back of the house or offices. So I would say start with your sales floor, look at the bigger units, the ones that are using the most energy, because there's a lot of opportunity there.
Jenny, I think that's great advice, because a lot of retailers, quite frankly, they just don't have the capital to talk about some of the larger planning and replacement, so retrofitting existing makes sense. Here's my second question for you. What I love to hear was how you talked about fan energy, part load, but it's also critical to adjust the outside air damper at the same time. What are some of the biggest pitfalls that people run into because they haven't incorporated your controls or your retrofit strategy? What is the worst thing that can happen to them if they don't incorporate that? What's the downside?
Sure, and I think that varies based upon the facility type, but for those that have any kind of an exhaust fan going on, like a kitchen hood, and that is particularly impactful there, because the RTUs are actually being used to help provide some of the makeup air that the facility needs. But it's also important to understand, I think one thing that's really overlooked, it's a piece of advice that I'm increasingly sharing with people, is I believe the day is coming where there are going to be lawyers out, ambulance chasers, looking at class action lawsuits to go after retailers that have not provided code level ventilation. And so I think the ability to have the data that can show that you have a solution that doesn't just go after the energy savings to the cheapest method possible by just, say, adding a VFD, but you've done it in an intelligent way that helps to make sure that code compliance, and more importantly, the health needs of your occupants are actually being met. And those who don't, I really fear there's a day coming where these liability issues are going to start to manifest. So fresh air is important for worker productivity. It also not only makes them more productive, but their workers' ability to show up for work sometimes is undermined when they work in underventilated facilities. So that's really what that integration is all about, is if we're going to upgrade these units, let's do it right, and let's don't just put a simple VFD in and think that solves the problem.
Well, thank you, Danny. And I'd like to officially thank everyone else on our panel here today. Mark Brucker, again, from Burton Energy Group, Mandy McDonald from Phoenix Energy Technologies, Andy Miller from FSC Lighting, and of course, Danny Miller from Transformative Wave. It's a privilege, it's a pleasure, it's an honor to be with you all here today. And we hope that all those in attendance, if you could just pick up one thing that was of value to you, hopefully today's session was great. So we will be closing out today's session. Again, you'll get a survey to your email, and if you'd like a hard copy of today's session as a PDF, we'll be happy to share that, as well as a certificate of completion. So thank you again for joining us here today. Have a great afternoon. Thanks.